Trig graphs on the TI-84. Let's see what our graphing calculator can do as far as graphing our trig functions. We'll start with y equals sine x. Now, a few comments first. We do need to make sure that we're in radian mode. The input to our sine function is just a real number. We have learned that we can think of that number as an angle in radian measure. So make sure you're always in radian measure for trig graphing. To enter in my equation, I go here to the y equals area, and I'll type in sine x using our sine button. X is this button right here. Close off the parentheses. And then normally when you draw a graph, you need to tell the calculator what portion of the graph you want to see. The nice thing with our regular trig functions is there's a pre-built window in the zoom area. So if you hit the zoom button, choice 7 is Z trig. And that provides a pretty nice window. We can see exactly what Z-trig gave us by going to the window button. And here we're provided with the smallest x, the smallest y, the largest y that we're seeing in that picture. So let's see. We know that 2 pi is around 6.28, so it's showing us a little bit beyond negative 2 pi and positive 2 pi in the x direction. Now maybe you recognize this number, 1.57. That's pi over 2. That's half of pi. X scale means that's how often we're seeing a little tick mark on the graph. So it's counting by pi over 2's, just like we did when we drew the graph by hand. On the y-axis, we're being taken from negative 4 to 4 and counting by ones. I'll hit graph to go back to the graph area. So you can see here counting by pi over 2's. Here's pi over 2, pi, 3 pi over 2. Here's 2 pi, 1 full period. Here's 1 and negative 1 on the y-axis. So it matches what we did by hand. One nice button is the trace button right here. If you hit trace, what you can do is you can type in an x and the calculator will take you to that spot on the graph. So how about I choose pi? I'll hit second pi and then I'll hit enter. And notice here's a decimal version of pi. It takes me to the spot pi comma 0. I could do that with any x value that I wanted. Let's try pi over 2. I'm still in trace mode, so I just typed pi over 2. Hit enter. Sure enough, there's pi over 2 comma 1, and you can see the cursor at that spot. Another great feature in the calculator is a table. It's here in blue above the graph. So if you choose second and table, here's the calculator giving you some decimal values for the sine function. Of course, these inputs for x aren't really what we want to see. We can go to table set, which is in blue above the window button. Table set allows us to state what x we want to start at. I'll leave it at 0, but instead of counting by ones, how about I change that to count by pi over 2, which is what we're used to. And then if I go back to the table area, now I'm getting counting by pi over 2, pi, 3 pi over 2, 2 pi, and there's our familiar values 0, 1, 0, negative 1, etc. Now let's see what happens if we make a couple of adjustments to our equation. So instead of doing y equals sine x, how about I graph this function? H of x equals 3 sine x plus 1. So to do that, I'll need to go back to my y equals area. I'll need to clear out the former equation. By the way, just a side note, these plots up here should never be turned on. If you have one that's turned on, make sure and go up to it, hit enter to turn it off, and then go back down. I need to type in 3 sine x plus 1, and then I'll hit zoom, followed by choice 7, Z trig, so that I can use that preset window again. And you'll notice it's not quite the same. The 3 and the 1 have had an impact on the graph. I've copied the graph here. Let's see which of our features have changed and which ones have stayed the same. Domain. Well, by now we know that these trig functions go on and on forever in both directions. And so, of course, again, the domain is all real numbers. The range has definitely changed. We were counting by ones here, so this is 4 up at the top. It looks like 4 is the highest and negative 2 is the lowest. So the range would be the interval negative 2 to 4, including the endpoints. How about the period? Let's see. If I think of this as my starting place, I have to figure out horizontally, how far do I have to go before the whole cycle starts over again? It hasn't started yet. It's going to happen right here, I think. You see how the upward part is going to start again? Right here and right here. Where is that? Well, let's see. We were counting by pi over 2's. So this is pi over 2. Let's see. Pi is next, and then 3 pi over 2, and then 2 pi. So it looks like our period has still remained 2 pi. Symmetry, I don't think we have any. If you flip it across the y-axis, it certainly won't land on itself. If you turn the graph upside down, it's not going to be the same picture. So this particular graph does not have any symmetry. How about the midline, that horizontal line that cuts the graph in half? Well, the top of the graph is 4, the bottom is -2. That's a total distance of 6. Half of 6 is 3, so I'm thinking it must be 3 away from those high and low spots. In a sense, I thought about the amplitude to figure out the midline. The midline is the horizontal line y equals 1, and then the distance from the midline to the top, let's see, from 1 to 4 would be 3. So the amplitude is 3. And then the 5 key points, remember the sine function goes middle, high, middle, low, middle. It's the spots within one period where the graph is hitting either the midline or the high or low values. Let's write down the coordinates of those points. So we've got 0, 1, pi over 2, 4, pi, comma 1, 3 pi over 2, comma -2, and 2 pi, comma 1. And then the last thing we're asked to do here is to find h of pi over 4. In other words, go to the h function, insert pi over 4 for x, and see what output we get. Let's try this by hand first. So I've inserted pi over 4 in place of x. It looks like I need to calculate sine of pi over 4. Pi over 4 is 45 degrees. I can draw myself a quick reference triangle picture here. 1, 1, square root of 2, and obviously sine of pi over 4 would be 1 over square root of 2, which simplifies to be square root of 2 over 2. So this down here becomes 3 times square root of 2 over 2 plus 1. Remember, sine pi over 4 was equal to square root of 2 over 2. In terms of simplifying, this becomes 3 root 2 over 2 plus 1. And that's probably a fine answer. The best answer, though, I think, would be to get a common denominator for the 1, to treat the 1 as 2 over 2. And that allows us to write the answer as a single fraction, 3 root 2 plus 2 all over 2. Now, can the calculator help us to verify that at all? Well, let's take a look. What I could do is I could take that answer we just got, go back to the main screen, which I do by second quit, and I could type it in to get a decimal approximation. Let's do that. I'll have to put that numerator in parentheses. The square root button is above the squared button. Be careful, you have to make sure an arrow out of it so that the calculator knows that you're done with the square root. I've closed the parentheses from the top, and then I want to divide all that stuff by 2. The decimal version is 3.1213. What I could do then is I could go back to my graph and I could trace the spot where x is equal to pi over 4. The calculator will take me to that spot on the graph, and sure enough, look at the y value, 3.1213. So that gives us some confirmation that we did our calculation correct. Thanks for watching.